Now, among these all the other Windows techniques, as I explained today in this video, we are going to discuss about the first one. Means previously I talked about this rectangular window among these window techniques. So first of all, today we are going to discuss about this rectangular window. The response of this window is rectangular, and that is why it is known as the rectangular window. Let the length of the window is capital M and Wn equals to 1 for n equals to 0 to 0 1 2 3 4 5 to m minus 1, and Wn equals to 0 otherwise. That means these are causal window technique, I can say, because it starts from 0 to m minus 1. Nothing is taken in this negative half. Means if this is my, in this nothing we have taken in this negative, so this is the causal window. Here we can say this is my rectangular window, right? So therefore mathematically we can say h dash of n, this is my FIR filter, means final output, equals to h of n, this is the IR impulse response, infinite impulse, and this is the Wn, where Wn is the window technique. Here we have taken the rectangular window. So you have to take the frequency response or the Fourier transform of the rectangular window Wn. So we know the Fourier transform f of Wn equals to capital W of n. Now in this continuous time domain, if I plot Wn, so Wn will be looks like where Wn equals to 1 for n equals to 0 to m minus 1. So in this continuous domain, if I put it 0 to m minus 1, this throughout it will be like 1 everywhere. Now if I talk about this discrete time domain, so in this discrete time domain it will be W of n. So 0 to m minus 1, all the sequences will be 1 because this is my 1. So this is my causal sequence, you can say. Here I have taken Wn equals to 1 for 0, 1, 2, 3, 4, m minus 1, and Wn equals to 0 otherwise. So here Wn equals to ft is nothing but we know about this Fourier transform of Wn. And again we know the formula of Fourier transform, that is n equals to minus infinity to infinity. Here the sequence starts from 0 to m minus 1, so that is why directly we have written 0 to m minus 1. The summation of n equals to 0 to m minus 1, the summation of 0 to m minus 1, Wn e to the minus j omega n. So finally we got Wn equals to f of t, ft of Wn equals to summation of n equals to 0 to m minus 1, Wn e to the minus j omega n. So here when Wn equals to, for 0 to m minus 1, 0 to m minus 1, the value of Wn equals to 1. So I gave here, I have written here 1, this is my 1, and e to the minus j omega n. So finally we got Wn equals to summation of n equals to 0 to m minus 1, e to the minus j omega to the power n. Why I have written like this? Because we know that suppose summation of p equals to n1 to n2, a to the power p equals to a to the power n minus 1 minus a n2 plus 1 by 1 minus a. So therefore we can write it here, Wn equals to e to the power 0. Why e to the power 0? Because e to the power n minus n1, n1 starts from this, I have taken n1 starts from 0, this is my n1 equals to 0, and n2 equals to m minus 1. So n1 e to the power 0 minus e to the minus j omega into m minus 1 plus 1. So 1 1 get cancelled by 1 minus e to the power j omega, e to the minus j omega. Therefore Wn equals to, I will get e to the power j omega equals to, e to the power 0 equals to 1 minus e to the minus j omega into m by 1 minus e to the power minus j omega. Now it can be written like here, Wn equals to, because to make it 1, I can take it to the power j omega into m by 2 into the minus j omega by 2. So plus and minus got cancelled, that means e to the power 0 equals to 1. So I have written like this, minus, for this e to the power minus j omega by m by 2 into the minus j omega m by 2. So minus minus got plus, and 2 into m by 2, that means j omega m. Similarly in the denominator section already we have written in similar fashion, e to the power j omega by 2 into the minus j omega 2 by 2 equals to 1 minus e to the minus j omega by 2 into the minus j omega by 2. So this is also minus e to the minus j omega. So equals to e to the minus j omega into m by 2 into the minus j omega m by 2 minus e to the minus j omega m by 2. We have just taken this common here, and in the denominator section also e to the minus j omega by 2 common we have taken, e to the j omega 2 minus e to the minus j omega by 2. So finally we got getting here e to the minus j omega m by 2 in the numerator section, and the denominator section we have shifted upper in the numerator. So that means this minus got plus, so e to the power j omega by 2, and in this e to the power j omega m by 2 minus e to the minus j omega m by 2 by e to the power j omega by 2 minus e to the minus j omega by 2. Since we know e to the power j theta minus e to the minus j theta by 2j equals to sin theta, so finally we can write here wn equals to e to the minus j omega, common we have taken, m minus 1 by 2, m minus 1 by 2 into sin omega m by 2 by sin omega by 2. And this is the Fourier or frequency response of the rectangular window. This is nothing but the mathematical expression of this Fourier transform of omega n rectangle. To solve. Ready? Now how to solve this? The steps we have summarized in some steps. 4. So first of all we have to find out the frequency response of the filter to be designed. Sometimes it has been given in our questions. If it is given, then no need to do it. That means this is my h of j omega. Number 2, find the unit sample response hd of n, just like h of n from the h capital D of omega. That means if it is given by taking the inverse Fourier transform. In the previously we have taken the Fourier transform here for this omega, but inverse Fourier transform we know the formula, that is hg of n equals to 1 by 2 pi integration of minus pi to pi hd of omega e to the minus j omega e to the j omega and d omega. In the step 3, the output of the step 2, i.e. this one hd of n, is infinite duration sample, but you have to make it finite sample duration, means having the m length m. But this can be done by applying some appropriate window techniques. Among these all other window techniques, means 6 window techniques, we can choose any techniques. So mathematically, already previously I told you that h dash n equals to hd of n into wn, and wn is nothing but the window techniques, and this is hd of n equals to the inverse Fourier transform of the given sequences ht of omega, right? The last one, if needed, find the frequency response of the given FIR filter, means finite impulse response filter, h of e to the power j omega equals to, and summation of n equals to 0 to m minus 1 h of n. This is my h of n to the minus j omega. Now if I do questions, it will be far clear and you will get a better visuality for these things. It will be much better for your understanding purpose. So we have taken a question, that is design a digital filter, digital FIR filter, given that h of e to the power j omega. That means here the first step 1 already given, equals to e to the minus j into 2 omega, where the range is starting from minus pi by 4 to pi by 4, and omega, that means omega lies minus pi by 4 to pi by 4, and h of e to the power j omega equals to 0 for other means pi by 4 to pi. So suppose, and the length is given to, the length is given length, that is m equals to 7. So we know that this is suppose a sequence. So h of mod of h of j omega, if I take h of e to the power j omega or mod of h of e to the power j omega, so mod of h of e to the power j omega equals to, it is nothing, that means 1 into e to the power j omega minus j2 omega. So 1 into e to the power j2 omega equals to cos theta minus plus j sin theta e to the power j omega. So that means whatever it will be cos theta minus j sin theta or cos theta plus j sin theta, will get 1 only. Just like we know how to find out cos square theta plus sin square theta. So it always gives you the 1. This is the formula how to find out from this. Now step 2, hd of n, and this is the inverse. Here already I have written inverse Fourier transform. Whenever this thing is given to us, we have to find out the inverse Fourier transform. And here the formula already we discussed, 1 by 2 pi integration of minus pi by 4 to pi by 4, because the range is given to minus pi by 4 to pi by 4. h of j omega e to the power j omega, that is e to the power minus j2 omega, e to the power minus j2 omega into e to the power j omega and d omega. So finally if I take it equals to 1 by 2 pi integration of minus pi by 4 to pi by 4 e to the power n minus 2, because this n minus 2 g omega d omega equals to 1 by 2 pi into e to the power j into n minus 2 omega by j into n minus 2. This is my limit is minus 5 by 4 to 5 by 4. So finally if I do here equals to 1 by 2 pi, so our hd of n will be 1 by 2 pi into e to the power j into n minus 2 by 5 by 4 minus e to the power minus j into n minus 2 by 5 by 4 by j into n minus 2. And upon simplifying this we are getting 1 by pi into n minus 2. Inside this it is j into n minus j n minus 2 into pi by 4 minus it is minus j n minus 2 into pi by 4 by 2j, because what we did here, this j we kept here and this n minus 2 outside the bracket we have taken, right, and these two already we have taken here. So 1 by pi into n minus 2 into sine n minus 2 by 5 n minus 2 into pi by 4, because from the Euler's rule we know that e to the power j theta minus e to the power minus j theta by 2j equals to sine theta. So finally we got hd of n equals to the inverse Fourier transform of h of e to the power j omega, and that we equals to sine of n minus 2 into pi by 4 by pi into n minus 2, this equation. Now suppose we have taken the sample length 7, right? So length 7, whenever we are going to do here, coming here, so that means we have to find out h, putting this n equals to 0 to n equals to m minus 1, 0 to m minus 1 we have written here earlier, 0 to m minus 1. So h of hd of 0, just putting the value of n equals to 0 here, we are getting sine into 0 minus 2 into pi by 4 by pi equals to pi into 0 minus 2. So here we are getting sine into minus 2 into pi by 4 by minus 2 pi. So minus 1 sine of minus pi by sine of minus pi by 2 equals to minus 1 by minus 2 pi. So finally we are getting here 1 by 2 pi for this h of hd of 0. And when n equals to 1, then just we are putting the value of n equals to 1, hd of n equals to hd of 1 equals to sine into 1 minus 2 into pi by 4 or into pi into 1 minus 2. So sine minus pi by 4 by minus pi equals to minus sine minus pi by 4 to minus 1 by root 2 by minus pi. So this will be minus 1 by root 2 pi, minus minus got cancelled. So this will be plus 1 by root 2 pi. But when the case is there, if I take n equals to 2, hd of n obviously n equals to 0. So the whole thing will not be exist. So what the things now we need to do, we cannot put the value when n equals to 2 here. So we have to go back to this formula, hd of n equals to 1 by 2 pi integration of minus pi by 4 to pi by 4 into e to the power j into n minus 2 omega d omega. Now if I put the value of n equals to 2 here, we are getting e to the power j 2 minus 2 0, and the same is there. So finally we are getting 1 into d omega. So finally here we are getting hd of 2 just 1 by 2 pi integration of minus pi by 4 to pi by 4 1 into d omega, and that is equals to hd of 2 equals to 1 by 2 pi equals to omega to minus pi by 4 to pi by 4. So finally we are getting 1 by 2 pi into pi by 4 plus pi by 4. This pi by 4 plus pi by 4 equals to pi by 2. So hd of 2 equals to 1 by 2 pi into pi by 2. So finally hd of 2 equals to 1 by 4. If I put hd of n equals to 3, so here you can check it. Sine 3, hd of 3 equals to sine of 3 minus 2 into pi by 4 by pi into 3 minus 2. That means sine pi by 4 by pi. So 1 by root 2 pi by 1. So that means 1 by root 2 pi here I am getting equals to 0.707 pi. We are not going to bother these things. Why? 4, 5 and 6. 0 to m. Not we are going to discuss. This is not needed. So how we are coming here? In the simplest way we can say that whenever this is my n, this IR filter, suppose H is impulse response, this is my window technique, H dash of n. And when it is given linear phase finite impulse response filter, H of n will be equals to H of m minus 1 minus n. And in these cases, suppose we have the 7 sequences here, 0 to 6, 0, 1, 2, 3, 0, 1, 2, these 3, and then 3 is the middle position, and then 4, 5, 6. Whatever the value we will get for this case, suppose if I do it 0, that will be same in 6. If I take it 1, it will be same as 5. If I to take 2, the same will be 4. So that means, and the 3 will be 3. So that means 0, 1, 2, 3 only if I take or find out these 4 values, so I will get the other values same. Here also hn the same thing. So that is why we are not going to find out this value directly. We can place this value same opposite. So h dash n, we now the finally find out, we have to find out this FIR filter value. This is our final output, h dash n equals to hdn into wn. Now as because I am going to talk about this rectangular window, so any window technique, whenever you are going to take, these are rectangular window I have taken. So rectangular window, what says? Rectangular window wn will be 1 for minus 5 by 4 to 5 by 4 and 0 else. Well, so that means here we have taken h dash n equals to hdn into wn, because this is exist only from minus 5 by 4 to 5 by 4. So finally we can say here hdn wn equals to 1. So finally h dash n equals to the only value of hdn. This is the total about the rectangular window. I hope you got understand about these things, and if you have any doubts you can ask.